Okay, I hope you can hear me. In an experiment to determine, this is kinematics, and if you have your book with you, you can check it. It's June 2012. In an experiment to determine the acceleration of free fall using a falling body, what would lead to a value that is too large? Kinematics is a leading topic. Kinematics is a leading chapter in our mechanics section. There are the main sections are measurement, mechanics, electricity, waves, and nuclear. These are the main sections in our AS physics. So from the mechanics, kinematics and dynamics, these are two heavyweight sections which always appear in the paper. Like there are some topics like Ohm's law come every year, kinematics come every year. So this is one of them. So I have selected that. Now you have to see this MCQ. And the question says that acceleration of free fall using a falling body which would lead to a value that is too large. So it means he must have dropped something like this, and he's working out. This is the famous experiment of free fall, and he must be using an equation of like this. For example, he must be using an equation of motion to determine the acceleration of free fall. Let's see, if you drop the object from zero, from rest, you will get this equation. This is an example. G is called acceleration of free fall. As I said, as a plan, as I said that I will still focus, I will still try to focus on topical, and yearly we can also do. But I always found that yearly students can do very well if they are doing themselves at home with a timing clock or etc. And they can cover it themselves. And we should do that. I select a topic, and just like I have selected kinematics. So for the next class, you can also do some theory revision work on kinematics for me. Not much, just like quick revision. And we can do some paper 2 questions on that also. In an experiment to determine the acceleration of free fall. Now, one by one, air resistance. He wants too large. Too large means that value becomes bigger. So if I consider air resistance, the ball will come a bit slower. It will take more time. Time will be large. So if air resistance is present, T will increase. According to the equation, if T increases, G will decrease. He wants too large. So this is cancelled. Dimensions of the body are too large. Dimensions means bigger. Now, do you remember that the size of an object, does it matter? If there is no air resistance, size of an object, does it matter in value of G?
No, it does not.
It does not. And even if you remember a concept, I want to get it back. The size, the dimensions measure time greater than measure time get longer than true time. So if t is more, g will be less. So I have worked everything, every option. Now he wants too large, bigger value of t. So what should be the answer?
C.
Yes. Which feature of a graph allows acceleration to be determined? Which feature of a graph allows acceleration to be determined? Now,
The
A. How A?
not A, the D one, the gradient.
Ah, good, fine. That's I was saying how it can be wrong. Yes, very good. It's a memory direct. If I draw a graph of velocity against time, gradient will be velocity upon time, and it is acceleration. The graph shows how the velocity of an object moving in a straight line varies over t is equal to 0 to t is equal to t. It looks like a sine theta sketch. Now, which graph represents the displacement of the object in the time? Now, this is a technical question that this is positive velocity and this is negative. This is positive velocity. When you take a U-turn, velocity becomes negative. Velocity is zero here, and zero in the start. Negative velocity means object has taken a U-turn. Now there are four options. First, you should decide the displacement, can it become negative or not? The object has made a U-turn, and do you remember that how we find displacement?
The formula for displacement.
Find displacement from, I have written the hint.
Your voice is breaking. I can't like understand.
Can you please check the voice is clear now? Ali, can you hear me clearly now?
Yeah, I can hear you now. Can you hear me?
Can you hear me now?
Yes, now I can hear you.
Okay, displacement is area of velocity time graph. So if so can you tell me that is it the displacement, the shaded one?
Yes, it will be the displacement. So what formula can we use for such a graph to find the area?
No, this maths. You do not need to find the area. You just have to decide that the graph, because the object is coming back, and should I say the displacement will, or should I say the displacement will keep on increasing when you return? You can see this is a first question: displacement will be negative or not? Do you remember? Do you remember when displacement becomes negative?
When it is traveling back, like when it was falling down the cliff from its original position.
No. It is not. Start from here. Displacement is plus. Still, displacement goes beyond it. Now, will the displacement be negative?
Yes, from the original position.
If it crosses beyond this, because both the green areas are equal. Both the green areas, you can watch travel forward and travel backward equal amount. So displacement can't be negative. Part number C, if you observe this one, displacement, if the object tell me how many times this displacement has become zero, twice or thrice. Suppose you had gone 5 meter and you return 5 meter. So when you reach back, I put a question mark. What would be the displacement here?
It will be negative from the original position now.
No. It has come back. You go and you come back to the same point. What would be your displacement? If you went 5 meter, you came back 5 meter, what would be the displacement?
It will be 0.
Yes, you got the point. It will be 0 once. It will not be 0 anytime in the journey. If you reach the same point back, if you reach the same point back, you will have a 0 displacement. So it means now you have to look for this. This can't be the case because there are 3 zeros. Here again, 0 displacement, 0 displacement, 0 displacement. It's not possible because this is saying 3 zeros. Now you start from here, you come back here, and it means the resultant displacement is 0. How this graph is the correct answer? You can see from O to A, displacement is increasing. You're going away. And from A to O, displacement is decreasing. And you can see the same situation here. The object was going forward and the negative velocity means it returned. When an object is coming back, displacement decreases. So when you leave your home and you're going to your college, displacement increases. When you're coming back to your home, displacement decreases. Overall, when you come back to your home, your displacement becomes zero only once. After leaving the home, it becomes zero once. This is the logic. This is the pattern of doing this typical dangerous question.
So and the B1 was wrong because it can't be negative, the displacement in this.
Because displacement, you can see this diagram. You can see this diagram. This is zero and negative. It becomes zero at this point. And if how it appears in the paper, the displacement can be negative. I show you that, for example, this is the graph, this is the going journey, and this is the return journey. Now carefully see, is it right that the return journey has a bigger area?
Yes.
Now, if I say this is 5 meter, this is 7 meter, then it will be 5 minus 7 minus 2 meter. That is the logic, that object has gone beyond the starting point. Now, can you see both the areas, both the green loops are they equal in size?
Yes, they're equal.
Okay, what it means, if this is 5 meter, this is also 5 meter, and 5 minus 5 will become 0. Area above x-axis is in one direction displacement. Area below x-axis is the displacement in opposite direction. Now, we move to our next question. The diagram shows a laboratory experiment in which a feather falls, a feather falls from rest. A long evacuated means no air resistance, vertical tube of length L. The feather takes time t to fall from the top of the bottom of the tube. How far will the feather have fallen from the top of the tube in time 0.50 t? Now, what is the formula? S is equal to ut plus half at square. Do you remember there were three main equations of motion?
Yes, I remember the three.
Good. So keep them in mind. And he asking how far does it mean he's asking for S? Am I right?
The distance.
Yes, distance. Very good. What about U?
Initial velocity.
What should I put for U?
Initially it will be 0.
Yes, you can see this one. What should I put in place of A?
9.81 plus 9.81.
You can put 9.81, or you can remember and you can put the calculation part. S is equal to half GT square. He's giving a time 0.050 t. Ideally, as I always advise in my past paper work, that do work in writing, especially if you have your past paper book and you open the book with me, you can see the year. Hopefully you can get the question. And if you get the question, work like I'm doing the work on the sheet. This will actually give you a very big understanding. It doesn't matter how many MCQs you do. Even you do 5 MCQs or 10 MCQs, but you do them in writing. That skill is unmatchable. Now, can you help me in solving this if you have written the whole work with me?
So I will not consider T in my writing in the calculator.
Because you're right. Answer is coming in terms of L.
This is
Uh,
coming 1.225.
no. Just a minute. You're right. Because answer should come in terms of L. The feather takes time T to fall from top to the bottom of the tube. So the total distance, let us see one thing. Let us make this equation. Let it go in terms of T. Just a minute. You're right. Because right now, can I solve it? I get 4.9 T square. This is equation number 1. Look, this bracket. He says the feather takes time T to fall from the top of the bottom of the tube. So what is the length of the tube?
L. So the
Yes.
distance we take as L.
This is the point. I have replaced it with L. This is my first equation. Now make the same equation again. Make the same equation again. Fallen from the top of the tube in time 0.50 t.
Will it be 2L or just L? Because it was half 80 square. So T will
No,
also be.
I have used 2 now. I have divided 9.8 by 2. That's why I'm getting 4.9. I use that 2 now.
So there's also 0.5 with T.
No. There was actually, I'm using the bracket first. See first the bracket. The equation 1 is coming from, I just made a mistake. And by mistake, I wrote 0.50 t. 0.50 to 0.50 t is the second case. Equation number 1 is coming from this bracket. If you read the bracket again. Now, read the line under it. How far will the feather have fallen from the top of the tube in time 0.50 t? Now I put 0.50 t. Now can you solve this equation?
So this will come as the same 1.225 as before.
1.225 t square. This is my, have you square 0.50?
Yes.
And multiply by 9.8
Yes.
and divide by 2, right? Double check the calculation.
So it is coming the same 1.22625.
1.226, 1.226, 1.225. Okay, fine. Now, can you tell me that I have got 2 equations? I need answers. You can see in every answer, distance is given in terms of L. How I can put L now? I want to replace T. Can you see T is not in any answer? So I want to remove T. Can you help me to remove T from the second equation? This is my first equation. From the first equation, if I make T square the subject, L upon 4.9. So can I get this T square here and I put here, will this remove T square from here?
Yes, we'll put this L over 4.9 in its place.
Yes. And why we are doing that?
Because this T square wasn't anywhere in the equation.
Right. That is why I always, this is something which I say repeatedly. Some people in my regular colleges and other where they always get say, sir, why you're repeating one thing again? I say that MCQs are not like oral. They are written documents and they are not coming from any memory. They just come from the sky. And the only thing you can get is start writing it because it involves maths, it involves physics. Sometimes it involves common sense also. That's a very big combination. Paper 2, you can always feel. Paper 2 is relatively much controllable than paper 1. Now, can you tell me how, can you solve this for me?
But there are two variables. How will I solve this?
No, no, you're not supposed to remove L. Just divide. 4.9 is dividing this number now. We need to keep L.
This is coming as 0.25 L.
Very good. Now, see what should be the answer.
B.
Very good. A very famous question of its time. And in the paper, it got a big problem for many people. Many people couldn't do it. But now you just have done this question and you see it's a pure algebra. It's a pure mathematical work. The markers M1 and M2 are set up a vertical distance h apart. A steel ball is released at time 0 from a point a distance x above M1. The ball reaches M1 at time t1 and reaches M2 at a time t2. The acceleration of ball is constant. It means whatever acceleration is there, I cannot say that it is g, because he has, but steel ball is there. So it's very looking to be that it's a free fall acceleration. Now we need to find an expression for acceleration. There are three equations of motion, and ball is released from rest.
So U will be 0.
U will be 0. So there are two sections of the motion. Let's solve for x. First, solve for x. Now select an equation. There are three equations of motion. I need, you can see the answers. I need height. I need time. I do not need velocity v, the final velocity. I have u0, that's fine. So there are three equations of motion. What equation should I use?
S is equal half AT square.
Yes. Why not 2s is equal to v square minus u square?
Because we don't have the final velocity.
Yes. So I'm assuming it doesn't matter that if I take it g or not, because he's asking to find that. In any way, I'm just assuming because a steel ball is there. So it will be half gt square. Can you help me and guide and give an idea that should I make g the subject?
So we won't take G as 9.81.
No, no. That is the point. I just make it clear, and it's better if I remove this g. Otherwise, it can give you a confusion. I make it a, because he has not mentioned it. I was taking it because it is close to this value, but now I know, I feel that I shouldn't take it because it can give a confusion. Now, can you tell me why I have made a the subject?
Okay, because it asks for the acceleration of the ball.
Ah, very good. Now, should I replace s by x and t by t1? This is my first equation. Let's make the whole distance as D. Can you tell me why I am not taking H directly? If I
Because it,
take H, can you use this U0? If I
no.
take H, no. If I take H, I will have to get another value on the position of M1. That would be a problem for me. So can you tell me the plan? I actually have to work out. You can see in all options, can you see H is present?
Yes. So we'll do H plus X.
H is present, okay. D is equal to X plus H, very good. And H would be equal to D minus H. So this is my plan. Now, can you write the same equation? S is equal to half AT square. This time, I make the subject A is equal to 2S upon T square, 2D upon T2 square. I have made two equations. Now, can you help me in putting the values here? What should I put for D? If I make D the subject here, D will be, can you tell me what D would be?
H plus X.
No, left side. I want to put D there, na? So I need a value for D.
2S over T2 into T2 square. T1 over T2 square into
D
T2
would
square.
be equal to,
The first equation into T2 square.
yes, ATT square upon 2. Is it right? In place of D, I'm writing AT square, T2 square upon 2.
Yes.
Now, can you help me in putting X?
So X will be D minus H.
That is fine. But from from equation number 1, I need the value of X from equation number 1
So the A into T1 square
upon 2.
over 2.
Now I'm here. Can I take H common? Can I take, sorry, can I take A common?
Yes, A can be taken from.
And what about 2?
That can also be common.
I reach here. Now 2H help me to make A the subject.
So it will be 2H over this bracket. T2 minus T1 square. Square will be cancelled. No,
No. Oh,
no.
they are
So
in
D,
subtraction. I made A the subject again.
this was quite a challenging question, this one.
Yes. This is a very famous question. In the paper, majority people couldn't do it. And some people made a serious mistake in the end. They did the whole, but they thought T2 minus T1 would be whole square. Squares in minus are never equal to whole square. You have done O-level maths and you always have to remember that A square minus B square is never equal to A minus B whole square. This question is coming from a very famous topic called projectile. In the absence of air resistance, a stone is thrown from P and follows a parabolic path in which the highest point reached is capital T. The stone reaches a point Q just before landing. Q is just before landing. The vertical component of acceleration of the stone. So just quickly recall, in projectile, we divide the velocity in components. V cos theta, V sin theta. Do you remember in projectile, everything has two components except time. Velocity has two components, acceleration has two components, displacement has two components. What are those two components? These are horizontal and vertical components. Everything has two components, horizontal and vertical components. He's asking for vertical. Vertical component means they're talking about free fall acceleration. In projectile, air resistance is not considered, as he says in the question. So I'm taking A is equal to plus minus G. Can you recall for me, in a full journey, acceleration is the same or changes?
It is
The
the
value
same.
of Q. Yes. And a very tricky question, that acceleration is minus G for the whole journey.
Because it is
If
going up.
no, it's not going up, it's going up and then coming down.
So won't is it minus D for the whole part?
Yes, it's a good memory to call back, and this is a concept to remember. In a projectile, if a ball, whenever an object goes up and it comes down in the same episode, the acceleration is minus. Make it clear. If it's only upward, it is minus. If it is only downward, it is plus. But if it goes up and down, both, complete journey, then remember it is always minus. Now, after the discussion, G is the same for the whole journey. What should be
D,
the answer?
D.
B or D?
D as in doll.
Yes, perfect. A brick is dislodged from a building and fall vertically under gravity. Apparently, he says that, and then he makes it clear that air resistance is neglected. So when air resistance is neglected, it means acceleration is constant. Acceleration is constant means velocity is increasing at a constant rate. They're always tricky questions because you have to see the graph they have drawn is velocity against time or distance against time.
Distance upon time.
Yes. Very good. Acceleration is constant. Velocity is increasing. Now, if it is a distance time graph, will the gradient be speed or velocity, you can say? Is it right that the distance time graph, gradient of distance time graph is velocity?
Yes, the
So
speed.
in this question, every option, the gradient is velocity. M is equal to V. And we have said that velocity is increasing. So now, which graph shows that velocity is increasing? Gradient is increasing.
Uh, B
First
is
of
not.
all, I'm neglecting B. Why I'm neglecting B?
It's a decreasing gradient.
No, it's a constant gradient, straight line. Remember, a straight line means constant gradient. C is wrong. Why C is wrong?
Constant
Straight
gradient.
line. Yes. And what we need? What type of gradient we need?
Increasing. So D is increasing gradient.
D is increasing. Do you know, interestingly, A is also increasing. They both are increasing gradient. Both graphs are getting steep. Remember this word, gradient increasing means the graph will be getting steeper. The graph will be getting steeper. So A is getting steeper and D is also getting steeper. How should I decide between A and D? Can you tell me about height? What A is saying? Height is increasing or height is decreasing? The graph is coming down.
The height is decreasing because it is falling down.
What about this graph?
It is increasing in this.
Achha, now read the question. That is why AS level is famous for trapping students. Which graph best represents the variation of its height above the ground?
Then it is D because D is going above the ground.
Yes. So it means for 7, you have to decide between A and D. H is the height above the ground. So as the ball, think carefully again, as the brick is coming down, its height above the ground is increasing or decreasing?
The height will increase when it is going above the ground.
The brick is falling down, height is from the ground. So when the brick is coming down, its height from the ground is increasing or decreasing?
If it's falling down, then decreasing.
Decreasing. Now you reach. Answer is A. So it means in MCQs, every line is a challenge, and that is why you have to work more closely on their wording. Normally, when you fall something, normal case, when you drop something, its height decreases. That's a logical thing. When you drop something, when aeroplane is coming down, its height from the ground is decreasing. That's a very common thing. But obviously, you have to read it carefully. So if there is a trap, number 8, a projectile is launched at point O and follows the path OPQRS as shown. Air resistance may be neglected. Projectile velocity has two components. Like this. Which statement is true for the projectile when it is at the highest point Q of its path? When it reaches the highest point, do you remember that velocity y component becomes 0 and only the horizontal component left? At the highest point, vertical component becomes 0 because it's not going upward or downward anymore. Velocity horizontal component is left. For the whole journey, I already had mentioned, A is equal to minus G.
So
Now,
B
one
will.
by one, one by one, can you tell me that projectile does not stop anywhere? So can its kinetic energy be zero at any position?
No.
Because for kinetic energy to be zero, the object has to stop. Acha, the object does not stop, and you remember that momentum is equal to mass into velocity. That will not also be zero. I have narrowed down the options.
So B will also be wrong.
Horizontal component of residual velocity is zero. Very good.
A is
And
the
what
remaining.
how A can be right? Option is narrowed down to A, and fine if A is the only option. But do you remember in projectile, as I just said, every component has two, every quantity has two components, horizontal and vertical. Now, this is the horizontal component. Do you remember horizontal component remains constant in projectile?
Acceleration will be 0.
Yes. So we have started kinematics, and this is a way we are revising also, and we are building our concepts. And because when I remember when we started this tuition, we just did kinematics very quickly. Kinematics and dynamics are pillars. They are the huge pillars of our physics. They are the first and questions, and we should work on them. And what favor you can give me, you have the notes with me, and you have the notes with your college also. So revise this topic and mark your queries, and we will do more questions on kinematics so we can improve it. Then we should do dynamics. These two are very important topics. So we keep it up to here, and we will do it inshallah in our next class. Allah Hafiz.
Hafiz.
experience.